Okay, so 3C is we're going to be conducting a regression analysis of data. So this is where we give you some data and then we're going to get you to go through the whole process. We sort of did it yesterday anyway, so let's have a look. So we've been given this data here. So we're going to use this example down here, the birth rate and life expectancy of 10 countries. So we've got the first thing we want to do is decide which one is the EV and which one is the RV. So we're actually looking at their life expectancy. So I'm going to write life expectancy is our RV and the birth rate is our explanatory variable. So the first part of a regression analysis would be to construct a scatter plot. So for me to do that, I would be typing in my lists into the calculator. So I've got birth rate. Oh no. Oh, sorry. So we're typing in our list. So I've sort of prepared them earlier. Okay, so let's just follow along. So we've got the two lists. If I was to construct a scatter plot, remember I'd go to the data page, pick the explanatory variable down the bottom and the response variable, and there we've got that. So we've done that. It then asked me, well, so we've done the scatter plot. Now it's asking me to find the correlation coefficient, which is R. So back on the list, I'm going to go here. So menu, stat calculation, A plus BX. Birth rate was the EV. Life was the RV. Click OK. If I move down there I go. So I'm just going to write the R value to 4 decimal places because that's generally what we do. So it's a negative, and so I've just checked down there. So that's to 4 decimal places. So this one, if we were describing this one would be a strong negative graph. And then it says write the least squares regression line. So this is where make sure we write the variable names. So I'm going to write life expectancy. You can abbreviate a little bit. We're going to let you go with that. So equals. Now I'm going to ask you to do this one to 3 significant figures. Just so because that's what you will be told to do it to something. So let's do 3 significant figures. So if I look up at the A value, it's 105 is 3 significant figures. And then the B value is minus 1.44. That's 3 significant figures. Now times the birth rate. Now the unit for birth rate, I think it was per thousand. So we'll just write that just to be safe. Now the next thing, it asks us to interpret the slope. So using your little templates that you had yesterday that I showed you, this one's a negative. So if I go to interpret the slope, remember that's the B value. So I'm going to write the negative one. So the slope estimates on average the RV, so the life expectancy, to decrease, so there's because it's a negative, to decrease by, now I just have to write 1.44. Don't need to write the negative because that's what decrease means. Decrease by 1.44. Now life expectancy was in years, so I'll just write 1.44 years when the birth rate increases by 1, and just put per thousand, like just the unit in bracket there. So per thousand. So there's me interpreting the slope. Then it asks me to interpret the intercept. So I'm once again using my little template. So the regression line intercept. So we know we're not going to get any marks deducted because we're writing exactly what it says. Predicts the average, the average value of life expectancy. So life expectancy to be, and this is where I put the A value. So 105 when the birth rate is 0. So if a country didn't have any more population, no more growth, they weren't reproducing, they reckon that people would probably live to 105. Okay, so now we're up to doing some predictions. So it's saying to predict life expectancy for a birth rate of 35. So you're just when you predict, you use the equation. So it's 105 minus 1.44 times 35. So if I do that on the calculator there, so I get 54.6, and then they asked me for one where it was 20 years, a birth rate of 20. So that I'm going to do the same thing but times 20. So on my calc, I'm just going to highlight that, change that to 20. So I get 76.2. So now it's saying comment on the reliability of these. So what we said before, if we go back to the original data, or you can just even look at the scatter plot. So the smallest X value was 26 and the largest X value was 43. Any predicting in between those two numbers is interpolation. So, and anything out of it is extrapolation. So if you look at this one, 35, this is interpolation and therefore reliable. And this one, because it's 20, so the 20 is outside. It's smaller than our smallest. So that's extrapolation. And it's not reliable because we don't really know. We haven't really tested it in that area. So then the next thing it's asking us to do is to interpret the coefficient of determination. So I often like to just put R squared there. And so I remember. Now let's just change this to, because we've got to interpret it, I'm just going to do it to the nearest whole number decimal place. So because R squared, I'll write it up here, was 65.11. When I interpret it, I'm just going to do it to the nearest percentage. So the coefficient, so just do it to whatever they ask you to do it to, of determination, tells us that, and this is where I'm changing it to a percentage, so 65% of the variation in life expectancy is explained by the variation in birth rate. Okay, so you must have that exact wording. So it must have variation in life expectancy is explained by the variation in birth rate. If you're missing some of the words, you're not right. So then we have to check that we actually had a linear, because we've assumed it was linear when we did all this. So we're just going to check the residual plot. So I'm going over what we did yesterday. So remember, we have our scatter plot. To get the residual plot, you must put the regression line on there. So I've just done that with the menu, analyze, show regression. Now once I've done that, I'm able to see the residual plot. So show residual. Now because we're going to say there's no clear pattern, so no clear pattern in the residual plot confirms our assumption that the association is linear. Okay. All right. So then that's what we did. And then that would be a full regression analysis.